So hi everyone, welcome to another video of Ground Zero। जैसा कि आपने टाइटल में देखा होगा, आज के वीडियो में हम बात करेंगे सुपर एलिवेशन के बारे में, जो कि एक बहुत ही इम्पॉर्टेंट कंपोनेंट है किसी भी एक हाईवे या किसी भी एक रोड का जब भी कभी कोई कर्व आएगा। हमारे लिए सुपर एलिवेशन इसलिए ज़रूरी है क्योंकि जैसे ही कोई भी कार, एज सून एज एनी कार टेक्स अ टर्न, whether left or right, it actually experiences a force, and that too opposite to the center of the curve, and that force is called as the centrifugal force. Now this centrifugal force has the intensity and the capability of either skidding the vehicle to the outer side of the curve, or to, you can say, overturn the vehicle towards the outer edge of the road. This is a very major problem when it comes to a track where the vehicle has to move with a very higher velocity. Yes, we are talking about a racing track. It can be a normal racing track, or it can be a Formula 1 racing track everywhere, or even if it is a very small road of any city or any urban area, there also we will require this super elevation. Now let's understand how the centrifugal force feels or how it looks like. So right now here I have performed a small experiment to show you that how centrifugal force looks like. As you can see, as soon as the vehicle takes the right turn, this ball on the dashboard moved towards the left side of the car. So this is the exact thing which I told you, that as soon as you take a turn, whether right or left, there will be a force on the body, that too in the opposite direction of the turn that you have took. Now in this example, the car did not skid or it did not even overturn. The reason is a small force which always help us, which always prevent our vehicle to skid or overturn, and that is the frictional force. In highway engineering, there are two types of frictional forces. One is the longitudinal force and another is the lateral force. In this case, we are experiencing a lateral friction force, and here we are going to use the coefficient of friction F, whose value is being recommended by Indian Road Congress as 0.15. So now we know that if we want to prevent our vehicle to skid or to overturn, we will be requiring the coefficient of lateral frictions. The force, basically the frictional force, is required. But what if the speed is so high that this frictional force is not enough to counteract this centrifugal force? What we are going to do in that case? This actually gave the birth to this concept of super elevation, or somewhere it will be also called as banking. Now in this, what we are doing is a very small or very simple prevention or very simple thing we are doing. We are just simply inclining the road. We are simply raising the outer edge of the road or the pavement. Now what it is going to do? Now as you can see, we are having the component of different forces. As you can see, there is a component of the weight, which is the force that is always acting in the downward direction of the body. There is a component of that as well, and there will be a component of the centrifugal force as well. But all in all, if you notice, you can clearly see earlier the frictional force that we were having, it was just having the weight component and the coefficient of lateral friction. But now if you will notice, we are also having the component of the centrifugal force, which is going to help us to avoid any kind of skidding or any kind of overturning. So this is the entire force diagram and all the components which we will be getting of all the forces on our vehicle. So with the help of these forces, there is a very small expression that we get, which actually give us the rate of super elevation with respect to the velocity, the radius of the curve, and the coefficient of lateral friction. It goes like E plus F divided by 1 minus EF equals to V square upon 127 R, where velocity is in kilometer per hour, radius is in meter, and E and F, they are unitless. Now if you notice, there are some recommended values of the maximum and the minimum super elevation by Indian Road Congress, as you can see here on the chart. Even if we take the highest value and we put it in the denominator of our formula, which is 1 minus EF, here E you can take as 0.1 and F you can take as 0.15, you will notice that it is coming somewhere around close to 1 only. And that is the reason why we sometimes don't consider 1 minus EF, and the formula remains simple: E plus F is equals to V square upon 127 R. Now in this, if we also want to get the design formula, there are two criteria that we need to follow. Number one, we have to consider the velocity as the 75% of the design velocity, because we cannot take the minimum velocity, we can't take the maximum velocity, because it is going to be problematic for the other vehicles. Another criteria is, since the frictional force is a self-occurring force, it is going to occur by itself. So as a designer, I cannot rely on any force which is coming by itself, which is not being designed by me. So that is the reason we will be considering this force of friction as 0 during the designing, because what we intend to say is that even if there is no frictional force, it is completely hypothetical still, even if there is no frictional force, I am going to design the super elevation in such a way that there will be no skidding and no overturning. So this is the final expression of your design criteria or mixed traffic condition. E is equals to V square upon 225 R. So if you want to design the super elevation, then this is the formula that we are going to use, and from where we will also have to check whether the coming value is less than or more than or in between the minimum or the maximum value of super elevation. So this was the entire thing about the super elevation. I hope you got the clear idea about the super elevation, and stay tuned for such more videos to our channel. Subscribe the channel, hit the like button, and also share this video with all the friends of yours. Thank you so much for watching. My name is Joshit Singh. I'll see you in the next video. Thank you so much.